Okay, so go to this example. Example 2. Example number 2. So for this example, we solve the problem with integer. So figure out that how we can solve. But actually, if you want to solve that, we still use um, simplex methods, right? Still use simplex method to solve for small problem. We deal with a small problem. So here we have 1, 2, 3, 4. But just only 3. Only 3. In this example, you can see that x1 and x2 is the integer. But in this case, just x1 and x2 and x3 integer. x4 is not integer. We have 4x. 1, 2, 3 integer. x4 not integer. So how we can solve the problem? Okay, know this. So the first of all, the same. You solve the problem by linear programming. You get the solution here. And after that, we trace with x1. Look at this is 1.25. So must be lesser than 1 and greater than 2, right? So actually in here we should write f1, everyone, f1. F1 in here. Because the solution here is to compare with this. It's not, it's greater than, it's not better than. So I will correct that later. So, okay. In here, you have f1 greater than 4, x1 greater than 1, x2 greater than 2, right? Because here that is the 1.25. You get that. And you add this in the formula here, so you get the solution. If x1, x2 greater than 2, you get x2. No solution. X1 greater than 2 is no solution. Okay, so right now we move to x2, sorry, x2. Here that is the value is 1.2, right? So rather than equal 1 greater than 2. So you solve the problem here. The problem here is maximize problem. Maximize problem. So maximize problem, but if you ask here, that is f1 greater than equal to f1. Here that is f14, so we must follow that. But actually in this stage you can see here x1 after x2 we consider x3, right? But in here we don't consider x3, we consider x1 equals 0. So why like that? So why everyone? Ngọc Diễm, hello Diễm. Do you have any idea? Yes, Diễm. Do you have any idea? My question is, so in here, why we don't consider x3, but why we consider x1? Why? Because x1 is not integer. Because x1 is not integer. So why we consider, so in here that it need integer, we consider if this one, why we don't consider x1 greater than 0 and x1 greater than 1, but we consider x1 equals 0 and x1 equal 1. Why not lesser than and equal to 0? Who have the answer? Because we know that the 10 and x1 is integer. It's easier to solve x3. Thank you. The answer from Sumai. So, do you have any other idea, everyone? Respond me, please. So, look at the board, everyone. So, I will explain. You have, look at this. Here, you have x1 lesser than equal 1, right? In the first state, in the first problem. You have x1 lesser than 1. So, you go to here. But in the question, x1 is greater than equal 0. So we have x1 greater than equal 0. But in this case, so x1 is not integer. So we must just show that it should be integer. If x1 is integer, so in this case, we probably have in two cases. We have x1 equal to 5 over 6. So we will have x1 lesser than 0 and x1 greater than 1, right? Normally we have like this. You must to resolve. So you have x1 here greater than 0 and lesser than 0. So we should have x1 equals 0 and greater than 1, lesser than 1. So we have x1 will be equal 1. So that's why we have 0 and 1. Because here is not integer, so we must resolve that. Reconsider. So if x1 equals 0, so you can see that x1, x3 that is integer, x4 is real number. So that is the optimal solution. But with x1 equal 1, so that is x2, no solution. So the optimal solution in this case, that is 0, 0, 2, and 1 over 2. Have any question for me? So, please, if you have any questions, don't hesitate. Hello, Tú.
No, I don't.
Don't have questions. Everyone, you hear me clearly? Any problem with the connection? So, okay, so let me move on another example. That is example for pure integer. Here's just all the variable in integer, like the previous example, like this example here, integer. Sorry, everyone, wait a minute. Let me check that. Sorry, someone knocked my door. Okay, everyone, in here we deal with the problem with a pure integer. Pure integer. So I want you to, because solve the problem here will take time. So I just give you the suggestion here. I want you to read that, the solution. If you have any question, you need me explain. So just let me know. Give you 5 minutes. Any question, everyone? So I send you the link. It's useful for you to use in showing the branching map. So let me share that with you. So why I cannot share this one? Let me leave and I will back. Sorry. Sorry. So everyone, can you hear me? Hello? Hello, hello.
Yes.
Okay, so you just hear me, right? You just hear me. Um, okay, let me, did you hear about I introduce the website for you? So I'm just talk about the website. You just input the information. You have many the category here. You can select that, and you can solve the problem. Which one if you want? For example, with branch and bound, you can select the branch and bound and input here, and you find a solution. Just give you. But go back with our lesson. So my home is near the speaker, so it's a little bit noisy. So do you feel noise, something noise from my side? If it's too noisy, I will close my door. Everyone, is it too noisy?
It, yeah.
Yeah, so, wait a minute, I will close it. Okay, is this better? Đang bầu cử quốc hội các bạn, nên cái loa phát thanh nó phát liên tục, nó hơi ồn. Bình thường thì nó không. It's better right now, right? So let me start with this example. So with example, we do the same. We solve the problem linear here, not 4.9, so you choose greater than 4, greater than 5, right? And here that is 6, greater than 6, greater than 7. So again, that is the optimal solution, right? 4 and 6, optimal solution. So we start in this, go to this way. So 3, 4, 4. So you should have number 3 and number 4. This no solution. Go to this. That is the 78. 78, that the optimal solution. Better than this. And another, we go to greater than 8. So get small solution and no solution. So if you go to this weight is greater than 5, so here x2 is 6.1, so lesser than 6 and greater than 7. Here no solution, we start with this range, go to this, and that is 5.1. So you have lesser than 5, greater than 6. So that is the optimal solution. Compare with this. You update the optimal solution. You have any question related with branching bound? Hello. Any question for me? If you have no questions, so we take the breaks. Take the breaks, and after that we continue with the practice. Okay, you take a 20 minutes break, and after that we will practice some example related with integer programming. Okay, see you after 20 minutes. Hello. Let me share. So what's wrong here? So let me leave. Hello, you can see my work file. So I don't know the problem. So let me. So wait a minute, I will fix the problem. Okay, better right now. So the file I'm sharing with you here. But you know that formulate that is a big problem for our class right now. So I want you to spend more time in practice formulation. Okay. So in the previous, we already studied what how you formulate, but we don't have a lot of examples for you to practice. So today, let's learn provide you some practice that help you to can master in the programming. Okay, for this example, so let's we solve the problem together. Everyone, please take note that summarize the question um, in your paper, and we can discuss. So right now, only they have this study seven classes. It's 3 credits, 3 hours per week. And what else? Okay, here that is the average hour per week she spent. That is the minimum grade she gets. So A is represent for 0.48 grade. B that is 3. C that is 2. D is 0. D is 1. F is 0. Wholly want to select the schedule. What will provide at least 3.2 grade point average. In order to continue receiving financial aid, she must take at least 12 hours classes per week. And so you have 1, 2, 3, 4 classes required. Require a lot of math, so Hollywood takes no more than. Here, she have list here, but she take no more than 2. So, and she need to take at least 3. At least 3, follow this. Only want to develop the class schedule with minimum number of hours. So right now, how we can formulate that. So you know that even though if you want to get a scholarship, so you must have a strategy to study how you can optimize the number of hours you study. So you see, this operation just help you a lot, right? Okay, I give you 5 minutes to think about that. Um, think about that is how we formulate the problem. Okay, so how many variable, everyone? Hello, how many variable? How many costs you have? 7, yes, because we have 7 courses here. So right now, she wants to minimize number of hours to work at each week, right? So it means she will think about which course she will study, which course she do not, right? So if here you can see that is a yes, no, binary. Select or not select, right? You have x1, x2, x3, x4. That is binary variable. And so right now, okay. So x1 equals 0 and x1 equals 1 if the cost is taken. You can see that right now we minimize number of hours. Here that is minimize, so minimize. Minimize number of hours. So each, that is the each hour corresponding with its cost, right? 6, 11, 8 until 7 here. Subtract 2. Subtract 2 crowd. It means here C must take at least is being greater than 12 hours classes per week, right? Here sees the number 3, so that is the number of hours you must to check that should be here is hour. Must be greater than is hour. So x1 is number 3. So C take at least 3 to follow here. Follow the cost. So the cost here corresponding with x1, x2, x6, and x7. So here, 1, 2, 6, 7. Okay, must be greater than 3, right? Must be at least 3. And she have 1, 2, 3, 4 costs here, but no more than 2 costs. She must to take. No more than is mean less than 2. This cost corresponding with x2, x3, x4, x6. And another, she wants to provide at least 3.2 grade points. Yes. That is point. So she wants get more than 3.2 grade point. So right now you can see that that is the hour, right? That is what credit is hour. So what is the first part here? So x1 CS, that is the minimum, that it must be B. So must guess is minimize the score B. B represents 3, right?
Teacher,
Hello?
why there is number 3 in the first constraint?
Here, number 3.
No, in the first constraint.
Yeah, because you spend 3 hours for each class. Here, each class you must to spend 3 hours. Okay, 3 hours of class time per week. So you must to take 3 hours for each class. But C want to take must take at least 12 hours, right? So here, sometimes you say you can take, but some course you can take, but some course you don't take. But must be here greater than 12 hours. Is clear? Hello. Is this clear? Who just asked me? That I answer your question? You spend 3 hours for each class, so you must greater than 12. Okay. So in here, look at this. So I move to this. I copy that. So what is it mean, everyone? 3 you time with 3 x1 plus what? 3 you time with 3. 3 you time with 2 plus what? 3 time with 3 plus what? 3 time with 2 plus what? 3 time with 1. So here is you have number 3. Okay. Here you plus what? 3 times with 3. Okay, so for the cost number 1, CSB, B corresponding with 3 grade point, right? C corresponding with 2 point. So here B that is 3 point here. And C that is number 2, number 3, number 2, number 1, and number 3. So that is the minimum the score they want to get. But they have 3 hours. So that's why I have with 3 hours. I spend 3 hours. And here, that is the hour, right? The hour they spend for the hour they spend for study 7 courses. So you check that's one you divide that must be greater than 3.2. So it means here in this sentence that will be equal point, grade point. You take the grade point That is time. Time with grade point. Time with x, right? Xi. You have sum. You divide for time. You divide for sum of time with xi. I from 1 to 7, everyone, must be greater than equal to 4. It's like this. Any question for me? Question?
Miss, I
Yeah.
still not quite understand why the part that we have to multiply by 3
Here,
for the point and the time.
grade point,
Yeah,
because you spend 3 hours for one course, right?
yeah,
You spend 3 hours for one course, but each course she get minimum score she must to get that is B. B is
yes.
corresponding with 3 points.
Mm,
Okay,
yeah,
so you time is x. If she take that xi here, that is yes or no. If yes, so you put this number 1 here. If no, you get the number 0, right?
yeah,
Okay, so that is with divide by sum. That is time and point. You see, you have time and point. Time you divide for time, so you have 1. X1 you divide for x1 is no, so you still have the gray boy. Here is the gray boy, right?
okay.
Okay. So any questions so far? So, question everyone? No questions, so I move on to another example for you. Let me see. So I have many examples. Another example. With the picture, please. So hockey, right? Hockey does have a team of 10 players. Lost with a goal. It's totally 11. I just to play with 3 position. Here we have 3 position. Two defense. Two winter. 1 center. It's to depend. Students have 1 center. Start again. Maximize the score potential project. Okay. So here that is the score for each player. Score corresponding with each player. So right now we want to maximize the scoring potential for projects. So everyone, how we can do that? Formulate. Okay. So we want to maximize, right? Maximize the score. So we have like this, the score here. Take to x1, x2, x3. So until x10. X10, right? That is, you take the score, you here x1. X1 is the binary. If the player start the game, so it's 1. If they do not, it's 0. Okay, so maximum. To ensure that 2 depends. 2 depends. So here x1, x2, x3, x4 equal to, just only 2 of them will be the depends. And 1 Windsor, this means one of them is Windsor. Here, one of them is the center, so you have the, the constraint like that. So suppose that the coach believes that if Stephen starts as one of the defense position, and Chuck should start at another one. However, if the Stephen does not start, if and then, see, so here, if Stephen start at one of the defense position, then Jack should start at other one. If Stephen do not start, so may not start. Write the appropriate constraints. So here Stephen, if they start. So it's x1, right? Chuck is x3. So the relationship between x1 and x3. If that happens, that will happen. So how we can write that, everyone? Remember? So we will have x1 better than equal x3. If like x1 equal 1, so x3 must be equal 1, right? But if x1 equal to 0, no. So here is not like this. So how we can write that, everyone? Stephen is x. So if this is equal 1, so the x3 minus x1 better than 0, so what? So here if x1 equal 1, so to be if equal to 0, should be equal to 0. So is this correct, everyone? So right now if x1 equal 1, right? If equal 1, so we will have x3 minus 1 greater than equal 0. So we will have x3 will be equal with what? Greater than. So in this case, what about solution here, everyone? Think about it. If remember, let me try. Do you have any idea? X1 greater than x3. So if x1 equal 1, of course x3 equal x3 equal 1. Not and both. So look at the slide. If no, if yes, we will have like this. Yes, it's x1 x3 greater than equal 0. Okay, so here if no, it's minus x1 plus 2x3 is greater than 0. So we should have two constraints. So it means x1 will be equal with x3, right? If here equal 1, so x3 should be equal 1, if 0 should be equal to 1. So in this case, x3, x1 equal x3. Here equal. Everyone, is it you understand in this case? Hello. So if like x1 equal 1, so here equal 1. But if x1 equals 0, Bảo Hùng, if x1 equal to 0, so x3 still equal 1 because 1 minus 0 greater than 0. So I think in your case not satisfied for both. So in here should be x1 equal 1, 0, so x3 equal 0. So do you have any other idea? So lemon tree, if you give the solution like this, so if x1 equals 0, if x1 equals 0, so x3 can be equal to 0, right? Equal 1, right? So it's not satisfied because they say that if that happens, another happen. If not, do not, so another do not. So I think this varies. So the question says, suppose that the cost believes that if y best start at one of the defense position and then Vincent and Robert should start at the one with winger position. So if here's yes, right, Vincent and Robert, Vincent and Robert should start at the position here. However, if do not play well together, so the coach doesn't want both start again. So what do you think in this? What do you think, everyone? So it's x4, right? There is x5, x6, x6, and x7. So the first if and if select x1 is select, so you have x6 minus x7 here is less than 0. So it means if say yes, so two of them or one of them. So here that that can be one or that's one, right? So however, the Vincent and Robert do not play well. If no, so if no, so the coach doesn't want to start again. If that is equal to 0, and that equals to 0 and this equals 0. So if that happens, 0, so the cost don't want both of them. If that no, and both no. So I think in this case we can write it. check. So here is this first. If x4 1, so here one of them equal 1, right? So if no, here is 0, is 0. So do not play well. They played. So let's see what is 1. X4 than X. Robust is XA, right? Robust instead of 6 is A. Is A. And X4 lesser than, okay, X6 and X7 lesser than 1. X6 and X7. So let's see in this case X6 and X7 lesser than 1. And so I think it's not correct, right? X6 is 0, X here is 0, so must be lesser than equal 0. So what do you think in the number C, everyone? C question. C, hello, number C. No, so the meaning of this, if that is defend, they should start. Everyone think about this. I think it's X. So why they explain that why X6 and XA equal 1? X6 plus with XA equal 1. We mean here is equal 1. Y equal 1. Hello, can you explain that? Okay. Okay, it's good thinking. Thank you. So one of them should be like one of them will Vincent and do not play well. They play but do not play well, right? If they played but do not play, Vincent and or Robert should start. So the coach don't want both of them start again. What about both of them do not start? What about both of them? So it means here if x1 equal 1, Right. So I'll let you think about this, and I give you the answers later. Okay. If you think about this situation. So right now, let me move on here. The question, because we have no time, so I'm trying to finish this first. Do you have any other solution? Just leave in the chat box, so I will read that. So okay, right now we just play game. Play game. So let's start with the number 1. So if you select the question related with number 1, so you answer like 1A, 1B, or 1C. So I will know your answer. Right? Start with number 1, everyone. What's the following the statement is true? Suppose x1, x2 is the both binary, where xi equal 1 is the plane in the building at the location I. So if a plane is the view at the location I, xi will be equal 1, right? So the constraint a plane can be viewed at the location 2 only if the plane at the location 1 is viewed. So it represents like this, x1 rather than x2. So they have the assumption xi will be equal 1 if that is viewed, right? So right now they have the constraint x2 view if and only if x1 is viewed. So it means x1 will view this to x2 view. So they write it here. Is it correct or not? So the B, routing doesn't not necessarily provide a feasible solution, and feasible solution from the routing are not necessary optimal. So with routing do not necessarily provide a feasible solution. So which one is correct? Number C is it more difficult to solve the IB than LB? B is IB solution can be better than LB solution at the same problem. So everyone, hello, think about that, which one that is correct. So you leave the answer in the chat box. Hello, what's your answer? What about number B? I think A is correct, but what about B, everyone? Rounding is then not necessary to provide feasible solution, right? So I think it's number A is correct. Rounding is mean we round up and round down. I think it's number E. Number B is also correct. A and B, I think so. So for question 2, number 2, what the following statement is true? Routing an optimal solution to nearest integer will provide a feasible solution. If a view ID problem, all decision variable must be either 0 or 1 in the optimal solution. Okay, I'll let you read that and select the question. Select the answer. Hello everyone. Is the question number A? Question number 1A is not correct. A is not correct. It's the solution is number B, 1B. So why? Because if you write like this, right? They said that only if equal, only if this one equal 1. So x2 equal 1. But even though here x1 equal to 0, so x1 equal to 0, so x2 can be 1. So this formula is not correct. So the right answer that is B is not correct. So for C, for 2, number 2, the correct answer that is a mixed integer problem, only sum of is integer amount. So number 6, okay, it's number 6. Because sum of decision variable is integer. It's not all, just some of them is integer. Because that means they still have real number. So question number 3, everyone. Question number 3. So which one, everyone? Number 3. Everyone, you still there? So the question, okay, the question is, if x equal 1, the department is banded. If equals 0, it's not banded, right? So which one you select? Yes, it's D. So because x1 equal 1, x2 must be equal 1. x1 equals 0, here x2 must be equal 0. So the right answer is number D. 3D. Okay. So move to another question. We have a lot of questions, everyone. That is time for you to play game. I don't want to put that in the Kahoot because You need time to think about that. So equal 1 if project selects, equal 0 if project does not select. To ensure that the project 1 cannot be selected unless project 2 also selected. So which one include the following constraints? Number 4, everyone. So that is no select, another is will no select, right? Project 1 cannot select unless project 2 is also select. No, it's not. If it means here, if 2 selects, so 1 do not select. So if project 1 cannot, yes, 4 is this. For this. So here is mean that when x2 equal 1, x2 equal 1, x1 will be equal 0, right? Here x1 equal 1, so x2 must be equal 0.
Miss,
Yes.
I have a question.
Mhm.
If 1A want to be right, then what the constraint need to be?
Sorry.
If
If what?
the question, the 1A from above,
8.
1A, not the 4.
You mentioned in 1A here.
Yeah. So it's wrong, and if you want to change it to the right answer, what the constraint need to be?
It's like if But you suddenly ask this again, so let me think. This y here is 0, 1, must be 1. So it's like, let's just try like this. So if x1, I think this is correct. X1 greater than x2, because if x2 here, so let's see, the plane x2 equal 1, only the plane 1 equal, no, here is so I will answer you later. Okay, so let's finish that. I think
Okay, okay.
we will think about that. So question number 5. Let's see. What about D? 5, number 5, the answer is x2 greater than 4. B, right? So greater than 4 and greater than 3. So here no greater than 3, just greater than 4. So answer that is number 5D, 5B, 5B. Okay. Everyone, any question here? Lesser than 3 and greater than 4, right? So here we just have greater than 4. So it's number 6. So who just asked me the question related with number 1?